Welcome to the Deep Dive. Today we're tackling a really fascinating intersection where artificial intelligence and blockchain technology are starting to collide and, well, more importantly, collaborate.
That's right.
You've sent in some fantastic material looking at this from all sides. How businesses are using it, new decentralized platforms that are emerging, and even how AI can help make blockchain itself, well, better.
Exactly. Think of it as taking two of the most talked about technologies of our time and seeing how they can sort of amplify each other's strengths.
Right.
So we're diving into research on AI and blockchain in business, exploring platforms like AIArena that are building AI in a decentralized way on the blockchain.
Okay.
Understanding how AI can address some of blockchain's, inherent challenges, and really getting to grips with what's being called the crypto AI space.
So our mission basically is to cut through the noise, understand the core of this convergence for you. What are the key insights? What's the real potential here?
And what does it actually look like right now?
Exactly. What does the landscape actually look like where AI and blockchain are working together? Okay, let's jump in. A core idea that keeps coming up is this incredible synergy between them. Your AI and blockchain fraud detection source really highlights this, suggesting that together they can create a much more powerful security net.
Yeah, and what's particularly compelling there is how AI brings its ability to spot patterns, even really subtle or totally new ones, to the world of blockchain transactions.
How so?
Well, it can sift through just massive amounts of data in ways that traditional rule-based systems simply can't, identifying potential fraud that might otherwise just slip through the cracks.
It's like upgrading from, I don't know, a basic alarm system to having a smart detective constantly analyzing every single data point.
That's a good analogy.
But the article also raises some crucial points about making this partnership work effectively. We need to think about the data quality, whether these systems can scale up, handle large applications.
Scalability is huge.
If we can understand why the AI flagged something, that's the explainability puzzle.
No, absolutely. That black box problem. And of course, the ever-present need for privacy.
Always privacy.
Those are absolutely vital considerations. If we connect this to the bigger picture, for this AI blockchain synergy to really take off and be widely trusted, we need to build these integrated systems so they're robust, transparent where they need to be, and crucially, respectful of user data.
Makes sense.
The AI in blockchain fraud detection piece also gives us a bit of a peek into where future research might be headed.
Oh, interesting. What sort of directions are they pointing towards?
Well, one key area is just improving the AI models themselves, making them more accurate, more stable, better at preserving privacy. That's kind of ongoing work always.
Sure.
Another is exploring new kinds of data sources that could feed these detection systems and refining how we prep that data for the AI to learn from.
Data prep is always a big lift.
Always. And finally, it touches on the critical aspect of making sure these AI-powered tools actually fit within existing legal and regulatory frameworks.
Right. You can't just build it in a vacuum.
Exactly. You can have the most advanced tech, but it needs to be compatible with the real-world rules of the game.
Right. That makes perfect sense. Okay, let's pivot a bit and talk about something really intriguing. Democratizing AI development using blockchain.
Yes.
You highlighted a source called AIArena, a blockchain-based decentralized AI training platform. The name itself suggests a pretty radical shift.
It is a radical idea and a fascinating project. The fundamental concept behind AIArena is really leveraging blockchain's core strengths, its decentralized nature, its ability to create on-chain incentive, to basically foster a more open and collaborative space for building AI. Think of it as trying to break down the barriers, make it less reliant on the massive resources of just a few big players.
So how does this, decentralized AI factory actually work? Who are the key players in this AIArena ecosystem?
Okay, so there are several important roles. First, you've got task creators. These are the folks, individuals, or organizations who define the AI training challenges.
They set the puzzle.
Exactly. They specify everything, the problem to solve, the type of AI model needed, how the submitted models will be judged. And interestingly, to keep things open, these tasks can even be reviewed by the community.
Okay, so someone sets the AI puzzle. Who tries to solve it then?
That's where the training nodes come in. These are participants who volunteer their own computing power and use publicly available data to actually train AI models based on the task creator's guidelines.
Okay.
Now, to participate, they need to put up some blockchain tokens as a stake, kind of like collateral.
Just get in the game.
Exactly. Their rewards are then tied to both the amount they've staked and, crucially, how well their AI model actually performs on the task.
Got it. So they're putting their resources and their money on the line. But how do we know if their AI model is any good? I mean, who checks the homework?
Good question. That's the job of the validators. They're responsible for evaluating the AI model submitted by those training nodes.
Okay.
The task creator gives them special evaluation data sets, right? Data the model hasn't seen. And the validators run these data sets through the submitted models to see how accurate they are.
And they assign scores.
They assign scores based on the model's performance. And just like the training nodes, validators also need to stake tokens. This influences which tasks they get assigned and how rewards get distributed.
So staking tokens seems like a key mechanism for both contributing and ensuring quality control. What about people who want to be involved but maybe don't have the tech skills for training or validating AI?
Good point. That's where delegators come in. They can stake their tokens with training nodes or validators that they believe will be successful.
Like backing a horse.
Sort of, yeah. It increases the amount of stake those active participants have, which can potentially lead to more rewards for them. And in return, the delegators get a share of those rewards. So it's a way for token holders to kind of passively participate in the ecosystem and support those who are doing the active contributing.
That's a clever way to broaden participation. You mentioned the training and validation processes. Can you give us maybe a simplified view of how those work on AIArena?
Sure. So for training, each training node takes the public data and uses it to, well, teach their AI model to make predictions or perform whatever the task is.
Right.
The task creator defines something called a loss function, which is basically a way to measure how wrong the model's predictions are.
Okay, like a score of how bad it is.
Pretty much. The training process involves repeatedly adjusting the model's internal settings, its parameters, until it minimizes this loss and becomes as accurate as possible on the training data.
So it's basically learning from its mistakes over and over. And for validation, how does that work?
For validation, a select group of validators gets a separate set of data from the task creator, crucially, data the models haven't seen during training.
The test set.
Exactly, the test set or evaluation data set. They use this to test how well the trained models perform on new, unseen examples. They compare the model's predictions to the correct answers in that data and use a specific evaluation metric like overall accuracy to give the model a performance score.
Okay, so we have models being built, rigorously tested. How does the platform actually decide who gets rewarded and how much? It sounds like it could be a complex equation.
It is a bit complex, yeah. It's designed to be a balancing act, really. It needs to incentivize people to commit resources, compute power, stake tokens, but also heavily reward those who produce the most accurate AI models and those who are best at evaluating them.
Makes sense.
So for each task, there's a total reward allocated, and the split between the training nodes as a group and the validators as a group depends on the total amount of tokens staked by each group.
Okay, so the total stake matters for the group split. And how are individual training nodes compensated then?
Right, so the final score for each submitted model isn't just based on one validator's opinion. No, it's a weighted average of all the validator scores.
Weighted by their stake.
Exactly. Validators with more stake have a greater influence on the final assessment. Then there's a calculation it takes into account the training node's rank based on their model's score, their total stake, including any delegated stake.
Okay.
And some platform-wide settings to determine their final payout. And the training node also gets to decide what percentage of their rewards they share back with their delegators.
Wow. Sounds like a pretty sophisticated system, designed to encourage both quality and participation through delegation. What about the validators? How do they get their slice of the pie?
For validators, the system looks at how closely their score for a model matches the final aggregated consensus score.
So accuracy matters for them too.
Hugely. Validators whose scores are more in line with the consensus and who have staked more tokens generally receive higher rewards. This really encourages validators to be accurate and honest in their assessments.
Right.
And just like with training nodes, delegators who staked with a particular validator also get a portion of that validator's earnings based on their delegation.
So built-in incentives all around for everyone to contribute honestly and effectively. That's clever. The paper also mentions different phases of validation to stop people trying to, game the system. That seems crucial.
Absolutely crucial. Yeah, AIArena employs this multi-layered approach to security. First, there's a submission phase, which runs for a set time and offers daily rewards based on agreement among validators. This encourages ongoing engagement.
Okay.
Then comes the final validation phase. This uses a completely different unseen data set to give a more robust evaluation of how well the models generalize. Makes it much harder for someone to just overfit to one specific data set.
Right. Prevents cheating the test.
Exactly. And finally, there's a challenging phase. Here, any validator can challenge a model they suspect might be plagiarized or wasn't legitimately trained.
Oh, interesting. What happens then?
The training node then has to provide evidence of proper training. They might use methods like proof of learning or maybe on-chain watermarking if they can't provide that proof, while the challenger receives the rewards that were allocated to the dishonest node.
That's a pretty comprehensive defense system. It seems well thought out. And is AIArena just like a theoretical concept, or has it actually been tested out in the real world?
This is where it gets really interesting, I think. The paper details how AIArena was actually deployed on the public-based blockchain's Sepolia test network.
Oh, wow.
Yeah, for about 7 months. And during that time, they saw hundreds of training nodes and over 1,000 validators actively participating.
Oh, that many.
Yeah, plus tens of thousands of delegators supporting them. And collectively, they produced a huge number of AI models across various training tasks.
Wow. Those are some pretty impressive participation numbers for a testnet.
Yeah.
What kind of results did they actually see? Were the AI models any good?
The evaluations were actually quite promising. They found that the AI models developed by the AIArena contributors didn't just outperform basic benchmark models.
Okay.
But in some cases, they even achieved better results than much larger state-of-the-art models on specific tasks.
Get out.
Yeah.
Really?
Yeah. For example, in the area of co-creation, helping write code, the community collaboratively built what they believe is the largest data set for the Move programming language.
The one used in some blockchains.
Exactly. That's a pretty significant outcome from a decentralized effort.
That's incredible. So the community-driven approach actually led to better results in some areas. They explored other types of AI tasks too, didn't they?
Yes, they also evaluated things like text-to-SQL. That's basically trying to translate natural language questions like show me all transactions over X amount into database queries you can run directly against blockchain data.
Useful.
Very useful for on-chain analytics. Another interesting one was the real-life simulator task. This focused on training AI to generate more realistic scenarios of everyday life.
Why? What's the issue there?
Well, current models often tend to produce, overly optimistic or kind of bland, unrealistic narratives. So they were trying to get AI to generate more grounded, plausible scenarios.
Huh. Okay, so it sounds like AIArena provides a really compelling, tangible example of how blockchain can be the foundation for a more open, maybe more collaborative, and perhaps even more effective way to approach AI development.
I think that's a fair summary, yeah.
Okay, so let's zoom out a bit now and think about the broader implications for businesses. Your source, artificial intelligence and blockchain integration in business, gives us that wider perspective.
Right. This study positions AI and blockchain as like the two major disruptive forces of what's often called the Fourth Industrial Revolution, or IR 4.0.
Okay.
And it highlights some key differences in their fundamental characteristics, which is interesting, right? Because they're quite different.
How so?
Well, for example, traditional AI often relies on centralized computing infrastructure, right? Big server farms. Whereas blockchain is inherently decentralized.
Yeah.
All right. AI decision-making can sometimes be opaque, that black box problem we mentioned, while blockchain provides a transparent, auditable record of transactions. AI models are often probabilistic. They deal in probabilities, likelihoods. Blockchain is deterministic, focused on verifiable facts, yes or no. And AI models can adapt, learn over time, whereas blockchain records are designed to be immutable, unchanging.
Those are some pretty fundamental distinctions. But as the paper seems to emphasize, it's precisely this convergence of, well, seemingly opposite strengths that's unlocking a ton of new possibilities for businesses.
Exactly.
They give some concrete examples of this happening in different sectors, right?
They do, yeah. In healthcare, for instance, the study points to blockchain's ability to securely store and manage sensitive patient data.
Which is huge.
Crucial. And that then allows AI to analyze that data for insights that can help doctors and researchers make better decisions. They mentioned Burst IQ as a company working in this space.
Okay.
In finance, the integration is leading to, faster, more transparent transactions, building greater trust in financial systems, less reliance on intermediaries.
Makes sense.
And supply chains. Supply chains, yeah. AI and blockchain are helping digitize traditionally paper-heavy processes, enabling trusted data sharing across all the different players, farmers, shippers, retailers.
Everyone involved.
Right, and automating transactions. IBM Food Trust is a well-known example, helping track food products literally from farm to table, benefits everyone from coffee growers to us consumers.
So these aren't just like theoretical ideas anymore. We're seeing real tangible applications popping up across different industries.
Yeah.
How did the researchers behind this study actually go about identifying these trends and applications?
They used a two-pronged approach, which is pretty standard for this kind of review. First, a bibliometric analysis.
Okay, what's that involve?
It's basically statistically analyzing a large body of academic literature papers, articles to identify the most influential ones, the key authors, the research trends, based on things like how often they're published and cited.
Got it. Mapping the field.
Exactly. And second, they did a content analysis. That's where they systematically examine the content of those influential articles to really understand the core themes and the intellectual structure of the research landscape. What are people actually talking about?
And what were the major themes that sort of bubbled up from their analysis of all this research?
They identified four main thematic clusters. The first was IR 4.0 and supply chains, focusing on applications within the industrial Internet of Things, using tech like federated machine learning, differential privacy, stuff like that in supply chains.
Okay.
The second was smart healthcare, looking at how AI and blockchain can prevent forgery of medical data, give patients more control over their health records.
Important stuff.
Definitely. The third was secure transactions, which actually included research on things like de-anonymizing Bitcoin transactions for law enforcement.
Oh, interesting.
And also mitigating identity theft. And the fourth was finance and accounting, exploring applications like automating accounting processes and preventing corporate fraud.
Wow, that covers a really broad spectrum of business functions. Did this study also highlight specific areas where businesses are particularly likely to see benefits from this integration? Like, where's the low-hanging fruit?
Yeah, based on their analysis, they pinpointed 10 particularly promising areas for business application. Let's see. E-commerce, finance and accounting, healthcare, intellectual property rights management,
Okay.
general management practices, marketing, smart manufacturing, social media, interesting one, supply chain management, and transportation.
That's quite a list.
It is, and for each of these, they found existing research exploring the potential of AI and blockchain working together.
That sounds like a very useful roadmap for businesses looking to innovate in this space. Did the study give any insight into how this field has evolved over time? Is it new or?
It did. The research indicated that while maybe the earliest work on integrating AI and blockchain for business started appearing around, say, 2017,
Okay.
the field really saw an exponential surge in activity from 2019 onwards.
So it's really picked up steam recently.
Massively. It suggests that while it's still relatively young, it's rapidly gaining momentum and becoming increasingly significant. They also identified some of the most highly cited influential articles, which is handy if anyone wants to dive deeper.
Good resource. It's clear the business world is definitely waking up to the transformative potential here. Okay, let's shift focus again slightly. You mentioned a source, artificial intelligence for demystifying blockchain technology challenges. How can AI actually help blockchain itself? Help it overcome some of its own hurdles?
Right. This is a really important perspective. We've talked a lot about how blockchain can enhance AI, but this source kind of flips the script. It looks at how AI's capabilities can be used to address some inherent limitations or challenges within blockchain tech itself.
Okay, interesting.
It starts by laying out the basics of blockchain, the decentralized ledger, immutability, security through hashing, consensual validation, all that.
The fundamentals.
Exactly. And it also gives a quick overview of AI and its key subfields, NLP, machine learning, deep learning, CNNs, RNNs, the usual suspects.
Right, setting the stage. Then what does it explore in terms of AI helping blockchain?
It then discusses the known advantages of blockchain security, transparency, at least for transactions, distributive nature, reducing single points of failure, standard stuff. But then it connects back to that fraud detection source by highlighting how AI's powerful analytical capabilities can be leveraged to identify potential vulnerabilities or even develop solutions to improve the security and efficiency of blockchain systems themselves.
So AI as a tool for blockchain integrity.
Precisely. For example, AI could be used to analyze network traffic for anomalies that might signal an attack is underway. Or it could potentially optimize the consensus mechanisms that blockchains rely on to agree on transactions, maybe make them faster or more energy efficient.
So AI isn't just a beneficiary of blockchain's features. It can actually be an active tool in making blockchain tech itself even more robust and effective.
That's the idea, yeah. A truly reciprocal relationship.
Cool. Okay, now let's move into what you call the crypto-AI intersection, drawing from that Galaxy digital report. This sounds like where things get really cutting edge, maybe a bit more complex.
Absolutely. This report really dives into the increasingly intertwined worlds of cryptocurrency and artificial intelligence, highlighting how they can mutually benefit each other in some really deep ways.
Okay.
A key point it makes is that crypto provides AI with something fundamental, a permissionless, trustless, and composable settlement layer.
Okay, let's unpack those terms a bit for everyone. What does it actually enable in practical terms? Permissionless, trustless, composable.
Okay, think of it like this. Permissionless means anyone can participate, right? No central gatekeeper saying yes or no.
Right, open access.
Trustless means you don't have to rely on trusting a specific company or person because the system itself, the protocol, is designed to be secure and verifiable through cryptography and consensus.
The code is law, kind of.
Sort of, yeah. And composable means different applications and services can easily be built on top of each other, like stacking Lego bricks. They can interact seamlessly.
Okay, so how does that combo help AI?
Well, in the context of AI, this unlocks some really exciting use cases. For instance, it can dramatically help the development of those decentralized compute networks we talked about, making the huge processing power needed for AI potentially more accessible and distributed.
Right, breaking the bottleneck.
Exactly. It can also enable the creation of AI agents, think autonomous programs that can actually perform tasks involving the exchange of value, like an AI negotiating and paying for cloud services using crypto all on its own.
Wow. Autonomous economic actors.
Potentially, yeah. And it opens up possibilities for more robust identity and provenance solutions. Think proving who you are or where data came from, which can be vital for combating things like Sybil attacks, fake accounts and deep fakes in the crypto space.
That's a great breakdown. Makes a lot of sense. And what does AI bring to the crypto table in return? Sounds like it's a two-way street.
Oh, absolutely, a two-way street. AI offers significant advantages to the crypto world, too. The report highlights how advancements in things like large language models, LLMs, can dramatically improve the user experience.
How so?
Well, for both everyday crypto users and developers. Imagine an AI assistant that helps you understand complex DeFi protocols, or maybe even automatically generates secure code for smart contracts.
That would lower the barrier to entry significantly.
Hugely. AI also has the potential to significantly improve the functionality and automation of smart contracts themselves, making them more intelligent, more responsive to real-world data or conditions.
Smarter contracts.
Exactly. And furthermore, the report points out that blockchains themselves, with their vast amounts of transparent, auditable data, could actually be ideal training grounds for certain types of AI models.
Using the ledger data itself.
Right. It's a rich data source.
It really sounds like a truly symbiotic relationship brewing there. However, the report also mentions a pretty significant hurdle: blockchain's inherent limitations when it comes to directly handling the massive computational demands of complex AI models.
Yeah, that's a critical bottleneck right now. Training state-of-the-art AI models, especially the big ones, requires just immense amounts of processing power. It's far beyond what most current blockchains can realistically handle directly on-chain without grinding to a halt or becoming incredibly expensive.
Even just using a trained model. Inference.
Even inference, actually using a trained AI model to make predictions or decisions while less intensive than training, can still be computationally costly, especially if you want to do it frequently on-chain.
So how are people finding ways around this fundamental limitation? You can't just run GPT-4 on Ethereum, right?
Not directly, no. This is where cutting-edge cryptographic techniques like zero-knowledge proofs, ZKPs, become incredibly important.
Okay, ZKPs. We hear a lot about those. Remind us what they do.
Sure. Basically, a ZKP allows one party, the prover, to convince another party, the verifier, that a certain statement is true or that a computation was performed correctly without revealing any of the underlying information or data used in that computation.
Magic. How does that help with AI on blockchain?
It has profound implications for both privacy and scalability here. It means that computationally heavy AI tasks, like running a complex model, can be performed off-chain where resources are cheaper and more plentiful.
Okay.
And then a small, efficient ZKP can be posted on the blockchain to quickly and cost-effectively verify that the result is accurate and the computation was done correctly.
So it's like outsourcing the heavy computational lifting, but still having a cryptographically secure way to trust the answer on the blockchain. The report also mentions ZKML. What exactly is that?
Right, ZKML just stands for zero-knowledge machine learning. It's really an emerging field specifically focused on enabling these verifiable AI model outputs on-chain in a way that's both privacy-preserving and cost-effective.
So ZK specifically for AI models.
Exactly. Projects in this space are developing tools and protocols that allow decentralized applications, DApps, to send those demanding AI computation requests off-chain to specialized providers,
Okay.
and then use ZKPs to cryptographically prove that the work was completed accurately and according to the correct specified AI model.
Is it ready for prime time?
Well, it's still early days, and generating these proofs can still be somewhat resource-intensive itself, but it's improving rapidly. It's really becoming a key technology for deeply integrating AI with decentralized applications in a trustworthy way.
That makes sense. The report also touches on the current crazy high demand and scarcity of powerful GPUs, graphics cards,
Yeah.
which are essential for training a lot of these advanced AI models. That must be another big factor influencing this whole intersection.
Absolutely huge factor. State-of-the-art graphics processing units, GPUs, are like gold dust right now. Incredibly high demand, long wait times. We even see major players like Tether making substantial investments just to acquire large batches of them.
Yep.
This shortage of readily available high-performance GPUs creates a significant opportunity for the development and adoption of decentralized compute systems.
Right, connecting the dots. Tell us more about these decentralized compute networks. How do they actually work?
They're essentially platforms trying to create a marketplace. The idea is that individuals or organizations with spare computing capacity, maybe they have GPUs sitting idle sometimes, can rent out that capacity to others who need it for AI training or inference tasks.
Like Airbnb for GPUs.
Kind of, yeah. It could help address the inefficiencies of the traditional centralized cloud market, dominated by a few big players, and potentially lower the cost of AI development and access to compute.
Any specific examples?
The report specifically mentions projects like Akash. They operate a marketplace for various types of compute resources, including GPUs, and have their own native token, AKT. They've been actively working to incentivize more GPU providers to list their hardware on the network.
And are there other players trying to tackle this GPU bottleneck in a decentralized way?
Yes, definitely. There are other projects like IO.net that are also focused on building these decentralized compute networks and attracting users who need processing power.
Is it working? Are people using them?
It's gaining traction. The report notes that while Akash has been around longer, maybe the initial adoption of the really high-end GPUs on the platform hasn't always met expectations, partly because owners of that super specialized hardware can often secure more lucrative direct contracts elsewhere, given the intense demand.
Market dynamics.
Exactly. But with the ongoing GPU shortage persisting, the landscape is constantly shifting, and these decentralized options could become increasingly attractive, especially for maybe smaller projects or specific types of workloads.
Interesting. The report also brings up Bitensor and its unique proof of intelligence mechanism.
Yeah.
That sounds like a very different approach compared to just renting GPUs.
It is a pretty distinctive approach, yeah. Bitensor draws some inspiration from Bitcoin's model, limited supply of its token, TAO, a halving schedule. But instead of Bitcoin's proof of work, which relies on solving kind of abstract computational puzzles, Bitensor employs proof of intelligence.
How's that work?
In their system, participants essentially mine TAO by running AI models that successfully respond to inference requests coming from the network. You get rewarded for providing useful AI computation.
So intelligence is the work.
That's the concept. And recently, they've introduced this idea of subnets. These are like specialized subnetworks within the main Bitensor network, each designed to incentivize specific types of AI-related behaviors or tasks.
Modular AI incentives.
Right. It allows for a potentially more flexible and efficient approach to coordinating decentralized AI efforts. However, it's also fair to say it's a relatively new and complex ecosystem. There are ongoing development challenges, discussions around network attacks, governance, how it all fits together. It's still evolving.
So the decentralized compute space is clearly still maturing, lots of different approaches, but it seems like a really crucial piece of the puzzle for enabling this deeper integration of AI and crypto. What about the really important issue of data privacy when it comes to AI? That's always a huge concern.
Massive concern, yeah. And the report highlights how the combination of decentralized compute and privacy-preserving technologies could offer some really compelling solutions here.
Like what?
Well, techniques like secure enclaves, basically protected areas of a processor, or even fully homomorphic encryption, FHE, which allows computation on encrypted data.
The Holy Grail.
Kind of, yeah, though FHE is still computationally very heavy. But these could potentially allow users to run AI models on their sensitive data within a decentralized compute environment without having to reveal that raw data to the model providers or even the underlying network infrastructure.
That would be a major step forward for privacy. People could use AI without giving up their data control. And how does ZKML, the zero-knowledge stuff, contribute to this privacy aspect?
ZKML significantly enhances data privacy in several ways, too. For one, it allows those decentralized compute providers to cryptographically prove they executed the correct AI model and got a specific result without needing to reveal the model's internal workings, its parameters, which might be proprietary or sensitive.
Okay, protects the model provider.
Right. And conversely, users can potentially run AI models on their own private data locally and then generate a zero-knowledge proof that they used a specific approved model to get a result without ever exposing their underlying private data to anyone else, including the blockchain.
Wow, that's powerful. Verifiable computation without revealing the inputs.
Exactly. It greatly expands the possibilities for conducting trusted AI computations in decentralized and privacy-respecting ways.
The report mentioned some key infrastructure and tooling projects that are trying to make ZKML more accessible, less like rocket science for developers. Who are the main players building these foundational layers?
Yeah, because generating ZK proofs for complex ML models is hard, so you need tools. Projects like EasyKL and Giza are specifically developing software libraries and platforms to abstract away a lot of that underlying complexity.
Making it easier to use.
Exactly. They help teams convert their existing AI models, maybe trained in standard frameworks like TensorFlow or PyTorch, into a format that can generate these verifiable ZKP proofs when executed. It makes ZKML much more approachable for a wider range of applications.
Any other examples?
Infernet, which was developed by a group called Ritual, is another fascinating example. It's envisioned as a network specifically designed for submitting AI inference requests and then verifying the results on-chain using, you guessed it, zero-knowledge proofs. Kind of like a dedicated ZK-powered AI Oracle network.
So we're really seeing the fundamental building blocks, the infrastructure, being put in place for the ZKML future. What kind of real-world applications are starting to emerge from this integration of crypto and AI, especially with these ZKML advancements?
We're starting to see some truly innovative applications bubbling up, particularly within decentralized finance, DeFi.
Oh, yeah. Like what?
Well, think about using ZKML for more sophisticated and private risk management protocols, or for developing automated yield farming strategies that can be cryptographically verified on-chain, proving they followed the rules.
Verifiable robo-advisors for DeFi.
Kind of, yeah. And even for creating on-chain credit scoring systems that can assess risk based on various data points, but without compromising user privacy, thanks to ZKPs.
That's a big one.
Huge. These emerging DeFi, decentralized AI finance products, are really trying to leverage the power of AI with the trust and transparency guarantees of blockchain.
Beyond DeFi.
Oh yeah, ZKML is also showing considerable promise in areas like identity, provenance, and privacy solutions more broadly, enabling things like, say, verifiable biometric authentication, proving it's you using your fingerprint, but without needing to reveal your actual biometric data on-chain.
Mind-bending stuff. And finally, the report touches briefly on the development of AI agent protocols. What's the big vision behind those?
Right. These protocol examples mentioned include Fetch.ai, Autonolas, SingularityNet, are focused on creating decentralized networks of autonomous AI agents.
Agents again, what do they do?
The idea is they can automate tasks and enhance the functionality of decentralized applications. Imagine AI agents that can autonomously trade on DeFi platforms based on complex strategies, manage your digital assets according to predefined rules, or perform complex information gathering or coordination tasks on your behalf, all within a decentralized and trustless framework.
So automating interactions with the decentralized web.
That's a good way to put it, yeah. Still early days for complex agents, but
Yeah.
the potential is there.
It really sounds like we're just scratching the surface, just at the beginning of understanding the full potential when you properly combine these two incredibly powerful technologies. Now, we did get a glimpse of some of the community's more critical perspectives with that Reddit discussion you flagged, titled, "Why the Main Narratives Around the Top Crypto AI Projects Are All Bullcrap," which is quite a title. But it's important to acknowledge there's definitely some healthy skepticism in this space, too.
Oh, absolutely crucial to maintain a balanced perspective and definitely engage with critical viewpoints. That Reddit discussion, while certainly, let's say, opinionated,
Yeah.
it does raise some points that are being actively debated within the crypto AI community. There were specific mentions of Bitpanda, for example, users questioning the distinct roles and incentives for validators versus miners within that network,
Okay.
questioning the actual utility and core value proposition of the TAO token beyond speculation, and raising concerns about the current level of interoperability or lack thereof between its various subnets.
So real questions about how it works and if it delivers.
Right. It just serves as a good reminder that this is a rapidly evolving field, often subject to a lot of hype, and it's really important for everyone to approach new projects and claims with a critical, discerning eye. Don't just believe the marketing.
Absolutely. Due diligence is key, always. So, okay, to try and bring this all together, what would you say are the most significant, the key takeaways from our deep dive today into this convergence of AI and blockchain?
Well, I think first we've seen a really powerful and clearly increasingly important synergy emerging. AI is significantly enhancing the security, the intelligence, the functionality of blockchain applications,
Right.
while blockchain in turn is providing this decentralized, transparent, and trustless infrastructure that could underpin a whole new generation of AI applications.
Okay, synergy is key. What else?
We saw decentralized AI training platforms like AIArena demonstrating a viable potential path towards more open, collaborative AI development, maybe breaking the hold of just a few big tech companies.
Democratization
Yeah,
aspect.
exactly. We explored the diverse and definitely growing range of business applications popping up across numerous industries, showing this integration is moving beyond just theory.
Real-world use cases.
We also examined how AI itself can be a valuable tool for tackling some of blockchain's own inherent limitations in security, efficiency, analysis.
AI helping blockchain.
Right. And finally, we really delved into that exciting, fast-moving landscape of the crypto-AI intersection, particularly the crucial role being played by decentralized compute networks trying to solve the GPU crunch,
Yeah.
and the really transformative potential of verifiable AI through ZKML, enabling trust and privacy in ways we couldn't before.
It's clear that while this field is still relatively nascent, and it undoubtedly faces its share of technical hurdles, adoption challenges,
Hype cycles.
definitely hype cycles.
The convergence of AI and blockchain holds just tremendous promise. Promise for creating systems that are more secure, more transparent, more efficient, and ultimately maybe just more powerful across a vast range of domains.
I agree. This integration really does have the potential to fundamentally reshape not just the technological landscape, but maybe even how we interact with data, how we build trust in digital systems, and how we innovate going forward. On that note, here's maybe a final thought for our listeners to ponder. How might the ability to verifiably prove the integrity and accuracy of AI computations on a trustless, decentralized ledger, how might that fundamentally change not just the technology itself, but our very notions of trust in all digital interactions? What does it mean for the future of data ownership, data usage, and how we govern these increasingly intelligent systems?
Deep questions.
Definitely a space worth continued exploration. Thanks for joining us for this deep dive.